What you are witnessing is completely real. What if I told you that the robots from your favorite sci-fi movies are no longer fiction? A Polish startup has created something straight out of a futuristic thriller, a faceless humanoid robot with actual artificial muscles that twitch, contract, and move just like yours and mine. This isn't CGI, folks. This is Protoclone, and it's already giving millions of internet users the creeps. But should we be amazed or terrified? Hey tech enthusiasts, welcome back to the channel. Today we're diving into one of the most fascinating and controversial robotics breakthroughs of the year, Clone Robotics' Protoclone. This isn't just another robot, it's what the company calls the world's first bipedal musculo-skeletal android. And unlike the smooth, plastic-encased robots we're used to seeing, this one features an anatomically accurate human skeleton with artificial muscles that contract and expand just like ours do. The video of this faceless humanoid has gone viral with over 34 million views, and for good reason. Some are calling it revolutionary, others are comparing it to their worst nightmares. Today, we're going to explore what makes Protoclone so unique, how it works, and what it might mean for the future of robotics and automation. Let's start with the video that broke the internet. Earlier this year, Clone Robotics released footage of their Protoclone suspended from the ceiling, its skeletal body twitching to life as its artificial muscles began contracting. The faceless android, with its bone-like structure and exposed muscle fibers, immediately triggered reactions ranging from scientific fascination to outright horror. One commenter called it their sleep paralysis demon, while another begged the creators to just draw a smiley face on the head, please. But behind the visceral reactions lies some serious engineering that deserves our attention. What makes this robot different from others we've seen like Boston Dynamics' Atlas or Tesla's Optimus? It's all about biomimicry, creating technology that mimics biological systems. While most humanoid robots use traditional motors and rigid components, Protoclone is built from the inside out like a human body. What truly sets Protoclone apart is its comprehensive biomimetic design, based on 4 integrated systems that mirror human anatomy: muscular, skeletal, nervous, and vascular. Let's break down each one. First, the muscular system. Protoclone features over 1,000 artificial muscle fibers, called myofibers, pioneered by Clone Robotics in 2021. These aren't your typical robotic actuators. They're designed to replicate mammalian skeletal muscles. Each myofiber can contract by up to 30% in less than 50 milliseconds and generate at least a kilogram of force while weighing just 3 grams. According to Clone Robotics, no other artificial muscle technology can match this combination of weight, power density, speed, and energy efficiency. These muscles are produced in monolithic musculo-tendon units, meaning the muscle and tendon are created as one piece to eliminate tendon failures. Each muscle attaches to anatomically accurate points on the skeleton, just like in the human body. Next is the skeletal system. Protoclone features 206 polymer bones, exactly the same number as an adult human. These aren't metal bones, but durable artificial polymers, connected by artificial ligaments creating fully articulated joints. This design allows for incredible flexibility with one-to-many and many-to-one joint-muscle relationships. For example, the shoulder alone has 4 joints connecting the shoulder blade, collarbone, and upper arm, providing 20 degrees of freedom. Each vertebra in the spine has 6 degrees of freedom, and the hand, wrist, and elbow together have 26 degrees of freedom. In total, just the upper torso without legs has an impressive 164 degrees of freedom, far more than conventional robots. The third system is the nervous system. This network of 500 sensors functions like a human nervous system, providing instant feedback and control. The robot has 4 depth cameras in the skull serving as eyes, 70 inertial sensors that monitor joint position and movement, and 320 pressure sensors providing muscle-level force feedback. All this sensory data feeds into what Clone Robotics calls Cybernet. Their visuomotor foundation model, running on an NVIDIA Jetson Thor inference GPU located in the robot's skull. This AI system processes all this information in real time to control the valves that regulate muscle contractions, creating smooth, coordinated movements. Finally, there's the vascular system. Just as our circulatory system powers our muscles with blood, Protoclone has what Clone Robotics describes as the most sophisticated hydraulic powering system ever designed. At its center is a 500-watt electric pump, as compact as a human heart, that can pump liquid at 40 standard liters per minute and 100 psi pressure. This artificial heart powers the robot's aquajet valve technology, which precisely controls hydraulic pressure throughout the entire muscular system. Each miniaturized 12mm valve can manage 100 psi water pressure with a 2.28 liters per minute flow rate, while consuming less than a watt of power. The system even includes a water-based cooling mechanism to prevent overheating. By integrating these four systems, muscular, skeletal, nervous, and vascular, Protoclone achieves a level of biomimicry that's unprecedented in robotics. Rather than simply looking like a human on the outside, it's built to function like one from the inside out. Protoclone isn't entering the humanoid robot scene alone. Several companies are racing to develop commercial humanoid robots. Figures robots are being tested in BMW factories. Apptronic's Apollo is headed to Mercedes-Benz production lines, and Agility Robotics Digit is being prepared for warehouse work. What sets Protoclone apart is its biomimetic approach. While most robots use rigid components and traditional motors, Clone Robotics is betting that a more human-like design will ultimately prove more versatile and adaptable. The company claims Protoclone will eventually walk, talk, and perform household chores. Although the prototype we see suspended from the ceiling looks far from ready for your living room, the technology is promising. The robot is expected to be available for pre-order later this year, though no price has been announced. The true significance of Protoclone may not be in its current capabilities, but in what it represents, a fundamental shift in how we approach robotics. By mimicking biological systems, rather than reinventing them, we may discover that evolution has already solved many of the problems engineers are grappling with. So, should we be excited or terrified about Protoclone? Perhaps a bit of both. The technology is undeniably impressive, pushing the boundaries of what's possible in robotics. And while the internet's horror movie comparisons aren't entirely unfounded, they reflect our natural response to something that blurs the line between mechanical and biological. What do you think about Protoclone? Is this biomimetic approach the future of robotics, or would you prefer your robots to look more, well, robotic? Drop your thoughts in the comments below. If you found this deep dive interesting, smash that like button and subscribe for more cutting-edge tech coverage. Subscribe to our newsletter, Robot Pulse, for detailed news stories about the world of robotics. Find the link in our bio.